Buckle up and get ready for some mind-blowing space facts. Did you know that over 4 billion tiny space rocks, known as meteoroids, are drawn into our planet's gravitational pull every single day? They can be anywhere from a speck of dust to a small pebble in size. Most of these space travelers burn up completely when they zip through Earth's atmosphere, but an incredibly small percentage manage to survive the fiery test and reach our surface as meteorites. Now that you're hooked on meteoroids, let's dive into some what-if scenarios that'll blow your mind. While most of these tiny space rocks aren't cause for concern, we can imagine a super-fast version of them to explore some crazy physics. But before we reach light speed, remember, no object with mass can actually hit that mark. Instead, let's just get close, not too far off, really, and see what happens when our meteorite zooms through space at an incredible pace, sending shockwaves throughout the entire solar system. Buckle up, because we're about to find out what kind of mayhem this could cause. Get ready for an epic space battle. We're launching a 30-meter, giant diamond ball towards Earth at an astonishing 3,000 kilometers per second. As it zooms through our atmosphere, things start to get wild. Air molecules begin fusing together in a process called nuclear fusion, creating plasma that's hotter than the surface of the sun. This intense heat could potentially vaporize our diamond sphere before it even reaches ground zero. But don't worry, we're not writing off this space rock just yet. It'll still manage to stay on course and make a massive impact when it finally smashes into our planet, leaving an unforgettable crater behind. The impact would unleash a jaw-dropping 1,000 times more energy than the most powerful nuclear bombs ever built. Talk about an extinction-level event. The area around the crash site, obliterated. But here's where it gets really mind-blowing. Despite this colossal force, our diamond sphere is still only zipping along at just a tiny fraction of light speed, 0.01% to be exact. So what would happen if we cranked up the throttle? The resulting crater would be truly astronomical in scale, leaving scientists and space fans alike scratching their heads in awe. As the heat from our cosmic crash intensifies, something crazy happens. The shattered stone gets blasted away at nearly the speed of light. We're talking 0.99 c. At this point, relativistic forces start taking center stage. The extreme energy shatters any bonds holding our diamond sphere together, and it literally tears apart into a swarm of individual carbon atoms. Now, here's where things get trippy due to an effect called Lorentz contraction. The fast-moving atoms would stretch out the sphere into a flat, pancake shape, all without us even noticing visually. Each carbon atom in our shattered diamond sphere now packs an enormous punch, about 70 billion electron volts of energy. Moving at incredible speeds, they zip right through air molecules as if they were ghosts. But here's the shocking part. Instead of passing harmlessly through the atmosphere, these energetic atoms start to pick up extra matter along the way. Air molecules are actually getting trapped inside our speeding carbon swarm, causing it to balloon out and carry more mass than when it first started falling. When it finally hits the Earth with a massive impact, the result is utter destruction. The diamond disintegrates completely, leaving behind a gaping crater and a cone-shaped tunnel through the Earth's crust. Imagine the cataclysmic event that unfolds when our supercharged diamond sphere crashes into the Earth's surface. It's an explosion so powerful, it shatters the crust and reveals a scorching glimpse of molten mantle beneath. The energy released is equivalent to 50 massive asteroid impacts, like the one that wiped out the dinosaurs. This kind of cataclysmic power is enough to unleash a mass extinction event, making it a spectacle none of us would want to witness. I think we can safely say, no, thanks to that intergalactic fireworks display. But let's crank it up a notch. What if our diamond sphere hurtles through space at a mind-boggling 9.9999999 times the speed of light? Now each carbon molecule becomes a tiny, supercharged particle packing an astonishing 25 trillion electron volts of energy, rivaling the power of particles in the Large Hadron Collider. If that's not enough, imagine this cosmic bullet slamming into Earth with a force equivalent to our moon's massive kinetic energy as it orbits our planet. Talk about a game-changing collision. But here's the thing, even at breakneck speeds like 99.99999 times the speed of light, our diamond sphere would still unleash unimaginable destruction on Earth. It'd blast a colossal hole straight through the mantle and send shockwaves that could melt the entire surface. That alone would likely wipe out all life as we know it. Yet, you want more. Alright, let's take it up another notch. What if we increase our diamond bullet's speed to an almost laughably impossible 0.9999999999999999999% of light speed? It's like trying to count grains of sand on all beaches simultaneously. Alright, let's take the fastest thing we've ever detected, the infamous oh my god particle, or as some call it, a speeding proton from outer space. This cosmic bullet zoomed into Earth's atmosphere back in 981 over Utah and hit speeds that were almost too close for comfort to the speed of light. We're talking mind-bogglingly fast here, so let's tap into its record-breaking velocity and see what happens when we use it as our diamond sphere's top speed. Here's the deal, this rogue proton, known as the oh my god particle, was cruising at an incredible 99% the speed of light. That's like you going Mach 299,999 in your sports car. When it smacked into our atmosphere over Utah in 981, it shattered into a gazillion particles and created a mind-boggling display. Now, scientists tried to replicate this event using the world's most powerful tool, the Large Hadron Collider, but they couldn't even come close. It was like trying to recreate a supernova in your backyard. Interestingly, similar cosmic crashes are happening right under our noses, about 4 or 5 times every year, and researchers still can't pinpoint where these ultra-fast particles are coming from. There's a strong hunch that they're originating from the vast explosion of galaxies. Basically, the universe's ultimate fireworks show. Let's dive into what might have propelled these speedy particles into the next galaxy. Literally. There are many theories, but one popular idea is that they were kicked out during the intense forces of galaxy explosions or black hole collisions. As for why they didn't slow down before reaching us, well, space is pretty much a vacuum, which means there's hardly any friction to break them. Now, let's turn up the heat and give our diamond ball the incredible velocity of the oh my god particle. That's 99% the speed of light. To put it into perspective, if you were traveling on this diamond ball, you'd experience time passing at only about 1% the rate it would here on Earth. With speeds this extreme, modern computer technology can't even simulate what'll happen next. It's like trying to predict a cosmic tornado. Here's how our high-speed diamond ball plays out. It zooms right through Earth's atmosphere without even breaking a sweat. Or should I say, without slowing down at all. As it burrows deep into our planet's crust, a shockwave of energy starts building up. This builds into an enormous cloud of superheated plasma and radiation that shoots out from the point of impact. Fast forward 40 milliseconds. This burst of energy has now encircled the entire far side of Earth. It's like a massive glowing halo expanding outward, lighting up everything in its path. Now, let's see what happens next. Our diamond meteorite smashes into Earth's crust and unleashes a massive cascade of particles. As this energy spreads throughout our planet, it's like a colossal oven firing up to super hot levels. The Earth starts glowing an intense shade brighter than even the sun. This cataclysmic event is so powerful that it sends our home planet careening off into a new orbit, but let's be honest, it won't matter. The Earth has reached its final curtain call. The enormous amount of energy released from this impact blows away the gravitational bonds holding everything together by an incredible 10,000 times. Here's what happens when our planet reaches its explosive finale. It blasts off into an enormous, expanding plasma cloud. The impact site becomes a non-stop powerhouse of energy, unleashing scorching hot jets of matter straight out into space. Meanwhile, the sun gets partially shrouded by the vast dust clouds generated from this cosmic collision. And guess what? The neighboring planets experience a super intense makeover. Their surfaces are stripped clean and left gleaming like never before as they get hit with an otherworldly high-energy shockwave. That's one heck of a light show. You made it to the end, and we're glad you did. So go ahead and give this video a thumbs up, and don't forget to subscribe for more out-of-this-world content from my channel.